So this is an optimization problem. And there's really only a few ways of asking this. So this is a really classic kind of problem. Here you have a farmer, and the farmer has a field, and you're kind of looking down at it. I don't know if you get the thing here. You're looking down at the field, and the farmer wants to divide up the field into 3 pens. So there's like a fence going all the way around, and then 2 little dividing fences. You get how that's going?
I do.
You know, because you have to keep the chickens separate from the
Pigs separate from the goats.
So, yeah, right. That's precise. You must have worked on a farm.
Yeah, I have. I'm from
So,
Wisconsin.
That's
so.
right. So here we go. There's some amount of fencing. I just made this up. There's 800 feet of fence, and we want to maximize the area. The other way that this problem can be asked typically is I know what the area should be. Like I might just say, hey, you want to have your pens 1,000 square feet. How can you do it using the minimum amount of fence? So really you can ask it 2 different ways. Here's how I'm asking it this time. So obviously I need some kind of equation which relates to the amount of fence. I'm going to say 800 equals, and I'll call this dimension x. And how about if I call this dimension y?
Excellent choice.
Thanks very much. So I need a piece of fence here that's 1x plus another x. I have 2 x lengths of fence, and 1, 2, 3, 4 y lengths of fence. Looking good? I need a second equation. I'm trying to maximize area, like the area equation. So the total area of my fenced-in farm animals here, I'll call x times y. This is what I want to maximize here. So this is the thing I'm going to take the derivative of. The problem, as you can see, Ms. Stewart, is I have 2 variables here. So it'd be nice if I could get it in terms of, as a matter of fact, I have to get it in terms of one of these variables. Either get rid of the x or y, it doesn't matter. What would be easier to solve for here, it really makes no difference. I'm going to solve for x. What do you think?
You mean you're going to have x in your equation?
Oh, I'm sorry. I'm going to get x by itself over here. So I'm going to subtract 4y.
Beautiful.
That's 2x. I'm going to divide everybody by 2. I did that because I figured everyone would divide nicely by 2. So I have x equals, that is 400 minus 2y.
That was a good choice since everything divides nicely by 2.
That's what I
You're really thinking.
Well, thank you. So that's what x equals. I'm going to fill it in for x right there. So my area, instead of writing x, I have this whole business, 400 minus 2y.
So you're just substituting that in
I
there.
did, and I still have another y. So this is my x, y. I think I can distribute that y. Area equals 400y minus 2y squared. One lovely equation with one variable in it. So now how do I find, this is really old hat, how do I find a maximum or minimum point?
Oh, that's right, because we're looking for a maximum area.
That's
So
all
you want
we're
to
doing.
find the maximum of that thing.
I'm just going to take the derivative. So a prime, the derivative of 400y, what a piece of cake that is. 400, the derivative of 2y squared. You still got me way over here?
I do.
It's 4y. How do you find maximum? This is a critical point. Well, actually, it's a critical point if I set the first derivative to 0. Remember, if the first derivative is 0 or undefined, you have a critical point. So let's see. Oh, this is going to work out beautiful.
It certainly is.
4y equals 400. So divide by 4. So y equals 100. Well, that's great. That's what y equals 100. I can fill that in right there. But you know, I want to be sure that I have found. I know this is a critical point, but I don't really know for sure if it's a maximum or minimum. I'm hoping it's a maximum. I'm trying to maximize area. I just want to make sure that's a maximum. So I'll do my little number line with the sign analysis. Again, this is nothing new. I have my 100 here. Pick some number on this side. What would be a nice number to pick on this side?
I don't know. 60.
I was going to go for 0.
Oh, 0. Why not? 0 is much better.
Killing yourself.
I am.
Okay.
You're right.
So I will fill in a 0 to my first derivative and see if I get a negative or positive. 400 minus 0. I'm pretty sure that's going to be positive.
I think so.
Put in something on this side. let's pick 1,000. I mean, you can put anything on your side. I'm gonna do 200. 1,000. I was just getting
Too
overwhelmed.
crazy.
Yeah, that was crazy. So I have 400 minus 4 times 200. Well, that's way bigger than 400. This is going to be negative. So what do these positives and negatives tell me again?
Slope.
So my
Like your
function
original
must
function.
go uphill and then downhill. So in fact, this critical point, 100, is in fact your maximum, which is what I was looking for. So if I want to maximize the area, let's just go back to this. I found y, but let's find x, because I actually want the dimension. How am I going to get x here? Let me see what you think.
Well, I would go to what you know. You know you have 800 feet of fence, and you know you have 100 is your y. I think you can figure it out from there.
That's going to work out beautifully. As a matter of fact, I have this equation already solved down to this point. I can put in 100. Is that going to confuse it too much if I stick in 100 at this point?
I think that's just
So
fine.
I've got x equals 400 minus 2 times 100, which is 200. I think x is going to be 200. So there you go, x equals 200. And I asked you to maximize the area. Well, these are the dimensions, and of course, if I multiply them, the actual maximum area is, if I was asking for that, 200 times 100, or 20,000. I guess it's in feet, so square feet. It's a big area.
Very nice. So basically you just came up with your equation, you got your area in terms of one variable, then you wanted to find the maximum, so you took the derivative, set it equal to 0, because you know a maximum, the slope's going to be 0. You confirmed it was a maximum, and then found your actual points. That is pretty cool. What are these called again? Optimization.
Optimization problems.